Yo, you're right, it's Tommy Allen here, and today I want to show you something really, really cool. So, what I managed to do is make physics calculated, mathematically accurate occlusion maps for Unreal Engine inside Comsol using FEM modeling. So, this is what we got. I made a video a while back about a school corridor, so I've just used that exact same model. And yeah, this is it. This is what it looked like. So, this is the occlusion map. We've got someone in the door. Shouting like a teacher, "Hey, come back here, Timmy!" And Timmy's at the end of the corridor. Can you hear it? Yes or no? That's what we're trying to see. So this is what it looks like. So how I got this into Unreal Engine. So I've got this beautiful graph, this information. How am I going to import it into Unreal Engine? So this was my workaround. It's very hunky-punky, chunky, hokey-pokey what I've done, but it works. And it looks and it sounds cool, and it can give artists the way to move around with occlusion. So let me get into it. So what I did was cut it into 2D plane. Most games are 2D. Okay, so that's what I went for. It was a 2D occlusion map, so there's no walking upstairs. And what I did was then export it as an image. I then went into Unreal Engine, and I turned it into a sprite. So a 2D image turned into a sprite, and I whacked the coloring up. So that was the first thing that I did. And let me show you, I made this blueprint. Okay, I'm just gonna take out the sound, and I'm just gonna show you how it works. So as we play the game, I have, actually, what I've got is this camera, and it's following my footsteps. So if you look at this square, okay, that's going to change color, and that's to kind of like debug what's going on to make sure I'm getting the right values. And it's going to read the red, green, and blue. So you're going to see things on the side. It's going to read the amount of red or the amount of blue, however coloring works, the amount of that, and it's going to then translate it into sound pressure values, or well, gain. So between -60 and 0 decibels. So let's just see it in action. So there it is. As you can see, it's changing color. Sometimes my feet get involved, and there needs to be, because it's just reading a single pixel in the middle. But like, say if I walk out, it's then green, it's going to mess up all the values. But as we get towards the white, it turns white, and so it's managing to read the things. Okay, and obviously it's very buggy, but it works. This isn't how I would physically implement it. It's just a workaround and to give a nice visual demonstration. So as you walk up and down, you can see the numbers changing. Obviously, in the white room, okay, minus 80 decibels. You can't hear him, but if you come down here, you can. So let's hear that through the audio. So I've got a little guitar sample. Where is it? Audio. Guitar sample. I actually need to make some more samples for these demonstrations. It's the same one every time. So yeah, this is what it kind of sounds like. I walked on the grass there. So that's what it sounds like. So it's kind of, accurate and mathematically. You kind of get these, these kind of, what would you call them? Anisotropies? I don't know, there's a technical word for it that sounds like that, where it's kind of these kind of fluctuations in color. That's because I used 1,000 hertz, but if we went up to like 2,000, 3,000 hertz, it'd kind of get rid of this, but it's really expensive to calculate. So the reason why I use the camera model, okay, it then kind of gives the artist, so maybe you don't want it so mathematically accurate. You just want to color in a map and be like, we're brand new, let's make it you know, a bit more sound occluding. So you could kind of, the sound audio artist could come in and I don't know, go into paint and use the spray paint button. I don't know how they do it. But they could literally make a occlusion map themselves and take that and use it, which is pretty cool. So I did another quick example. So I actually built the geometry into Unreal Engine for this one. And for the other one, I made the geometry and then built it out and worked the opposite way to make sure it could physically work. So don't save. So I had this kind of weird little map I've made. So we've got a window, or a little sound brick that's made out of grass, but that's where the sound's coming from. And we've got through the wall, we've kind of got little doorways where you can see the sound and it's seeping through, okay, which is pretty cool. And so we're going to run around here, and yeah, the hardest bit was actually trying to rematch the map back up, okay, because it's kind of implemented as an image. It's correct, but it's trying to then translate, because Unreal's in centimeters. I'm a physicist, I deal in meters, not like Americans in feet and inches. But here we go. Let's see what this sounds like. We're gonna get a few little jars that go outside the map. I haven't made the geometry solid. It's sometimes a bit annoying visually, but let's see what it sounds like. So same sample, different map, and you know, obviously we get little hot colors through the wall, and we got this little window here where we can see our sound source, the little grass box. Okay, and then down this corridor, it should get a little bit louder. Okay, so that's inside the room. That's on top of our speaker. Let me try and get out of the room. So the corridor blocks everything. Cool. So a little window. And another little window. Okay, so that's the kind of occlusion maps working inside Unreal built geometry, which is really cool. Using the kind of camera method, it, yeah, again gives the artist, they can actually kind of change how they want it to use by reading the redness of the graph. What also is quite interesting, if I was to use the physics engine, I haven't figured this out. This is what I want to kind of do next. Is I have a text version of this, and we get these awesome, you know, this obviously little graph. So it's taken loads of nodes. Obviously it's trying to stay at 1. I think that's to do with the FEM. But we kind of get these coordinates in X and the Y plane and all the kind of sound pressure nodes, which is super useful. So we could actually export this and somehow use it into Unreal Engine. What I think would be really good is if I took the ray tracing models. So let me get a picture of my ray traces. So if we took the ray tracing model that I made and we just get the early reflections, so we just get the first 4 or 5 reflections, and we could have, you know, sound pressure level, so you know, your first reflection, second reflection, and you could start then implementing this inside Unreal Engine through, instead of using a color map, you could just use, you know, raw data, which could be then quite cool. You could have the RT60s on, frequency kind of dependence. I don't know. There's quite a lot that I'm kind of excited to kind of get into, but yeah, that's what I've been making. I hope you enjoyed the video. I don't know if any of it's of use, but it's kind of cool interlinking different parts. Obviously the next thing I want to do is make boundary element, because everything I've done so far is in a closed room, and yeah, as soon as we go outside, well, obviously the area is bigger, we need to use boundary element method, so we can kind of transverse through, you know, open space, and it's less computationally expensive. But yeah, I hope you enjoyed that. I enjoyed making it. I always enjoyed making these. So I'll see you in the next one, and yeah, hope it's useful. Peace.